time to start the stream because sometimes doesn't. Hello, everybody, and welcome back to this series of interviews and videos that we do here today at Atlanta in the CMG Impact Conference 2023. I have with me another of the presenters for the day, Tyrone Astoria. I hope I'm saying it right.
Lastoria.
Lastoria, sorry.
No, everybody gets that one wrong.
No, and
It's like the hotel, right?
I knew I had a name, like clicked on something, but
Yeah.
sorry for that. Welcome, Tyrone. And for the audience that do not know you, who are you? What's the deal with you? What are you doing here?
Well, my name's Tyrone Lastoria, and I'm a software engineer with Broadcom. I specialize, or I work with Ops MVS, which is a mainframe automation product. Here at the conference, I talked a little bit about one of the features of Ops MVS, and that was something called System State Manager, or SSM. Commonly.
I was going to ask because for some of the audience that usually they are used to, how to say, not so much about mainframe, but nowadays the rage is the cloud and some of the new platforms. What is, first of all, the main difference for you with mainframe with the cloud? Why should we still be paying attention to mainframe?
Well, everything is eventually runs or connects to a mainframe, even the cloud, right? So everything originates from the mainframe. And the thing that Ops MVS does is it manages resources on your mainframe, or all the mainframes.
That's one that I want to keep shining out on these interviews that we're doing today, because you very well said it. The cloud has a mainframe behind, has several LRs and all this stacked up on top of each other. And the key difference is that it's at a deeper level where you are doing some of this instrumentation, monitoring, and checking what is the status of your mainframe, right?
Right.
But okay, sorry that I interrupted a little bit on that. I wanted to give some more clarifications because so many in the audience are like, yeah, mainframes, that's so 2000s before or something like that. But now, yes, please share a little bit about your talk. What were you sharing today earlier?
SSM, System State Manager. It's a feature of Ops MVS. It's designed to manage resources on a mainframe. The importance about doing that is that since the mainframe is the lowest level of everything, right? It's important to keep the applications that are running there running, right? So in the past, there were operators that would sit there at a green screen and monitor messages and things that came across on that screen that indicated the health of a resource.
I want to do a quick clarification. What do you mean when you are mentioning green screen? Because so many in the audience may have another VFX. We are live in the real place. This is not green screen. What do you refer to as a green screen?
Yeah, green screen is the old computer terminal, right?
The Matrix thing that we saw in the movie, right? The old
right, where you can access. Right, yep. There's no GUI applications on a mainframe green screen, right? So everything is done by way of commands, right? So you got to know what you're doing to type. You got to know the command to get access or to do what you want to do on the mainframe. And there's things called these panels, right? And they can have options on them, and that kind of simplifies the use of the green screen, right? It kind of, instead of you having to know the command or how to navigate around, you might be able to choose a menu option.
Does it? I think I know what you're talking about. Does it look a little bit like the BIOS booting screen of our laptops that you get like?
Yeah, it does.
Squares here, here.
It's a little bit more sophisticated than
No,
that.
I mean, just to
Yeah,
paint a picture for the
the
ones that do
BIOS
not
is
know.
really the beginning stages of like a PC. In the mainframe world, it would be what they call an IPL. Right, but still, you still have the green screen.
But the interface is a little bit like the BIOS, like those
right
squares that you can see and modify parameters and see what is the output.
Right, as it's starting up and do different things, they hit the right key and get into a different portion of that. Right, but still, you got to know what you're doing there, right?
Yeah.
Right.
So no. It's like again, I'm not sure if I should keep using the BIOS example, but you don't want to be messing around on those things if you don't know what you're doing.
True. And one of the things about a BIOS, even at that level, they'll have PF keys and they'll tell you what it does.
Yeah.
Right. So it's somewhat menu driven. Right. So that's a comparison at the BIOS level compared to like what I refer to as a green screen and getting into applications that way.
Okay.
So all this stuff that runs on the mainframe has to be brought up and down. It has to be monitored. And that's what Ops MVS does. And he does it with code, right? It's a specialized code called Ops Rex. More commonly known, Rex language is a pretty standard language in the mainframe area.
Okay.
It can even be extended to other items off the mainframe, like different operating systems. Cool. So, yes.
So, and with this, what is the interaction between SSM and the language? Are the commands or? Well,
SSM is really it's like a model. It's a state model, right? And these commands that you can, instructions more precise, that you can enter or you run a program that consists of several of these instructions, they can interact with StateMan telling him, okay, this resource is now up, this resource is now down, take some action based off of that. It can also say, go ahead and start the resource, or it's time to bring it down. And this is all done by way of these Rex instructions that are issued. And of course, there's interpreters behind that. I mean, it's a basic overview, but there's interpreters, language interpreters behind that can interpret what that instruction is and knows what to do with it, right?
Yeah, I mean, in the end, it has to be taken into computer language so that you can execute. Because even at some time in the past, I remember these translations. Can't remember if it was a C# or a higher level language, taking it into what was this language with the AB compressor controller?
COBOL.
No. Before COBOL, the one that you do for CPUs.
Was it? Assembler.
Assembler. Thank you.
Yes.
Yeah. So
yes, Assembler is still in use.
Yeah, big time, right?
And actually, that's interesting because the Ops Rex instructions, these commands, instructions that you're doing under the covers, right?
Translated into some sort of
those assembler instructions, those assembler modules are actually the ones that take those instructions and do the machine language that causes that instruction to do the thing the action that instruction was supposed to do.
And so why is it important? What was the point or what you wanted to come and share with the audience during your presentation today?
Well, it was a clarification of the offerings that Ops MVS has in this system state manager feature. Because as time has progressed, now Ops has been around, it's been a mainframe product since the mid 80s. So it's been around a long time and it's matured. And as it matures, we keep adding things into it, right? To keep up with the evolution of the mainframe.
Yeah, I mean, in terms of hardware, software, I'm sure even as we mentioned, this still assembly code, it keeps growing in capacity. Sometimes it's objects or now
Right. It used to be simple where, just start one thing and that was enough. Now you got to start 5 things to start one thing, right? So it gets more complicated. And when that one thing doesn't work, there's several things you might have to do with those 5 things that are supposed to be running. So there can be the complexity level has risen quite a bit as the mainframe has evolved. And to keep up with that complexity, we've had to provide different options.
New functions, new capacities,
new capabilities. Yeah.
Which ones would you say are new ones, or things that I'm guessing of from your presentation? Because you mentioned a clarification, meaning that there has been some sort of confusion, or
yeah. As we keep adding items to system state manager to evolve it, we've had to break it down into different items, right? So you can use this part, but maybe not that part. You have to choose one or the other. So it gets a little confusing there, right? So one of the things that this session does is to clarify that. Right?
Okay.
And in addition to clarifying that, then we're also able to make those different offerings more specific to what you may need. And that was the other purpose there, was to outline some use cases where you might want to go with this particular feature of StateMan as compared to this one.
So I'll put a pin on some of those examples. I would like to hear about them. But you mentioned that there are new functionalities, new capabilities that have been kept popping out, call it in a way. Which ones would you say are the newest, most relevant, or that you would point out?
Well, within System State Manager, used to be somewhat of a simple, you see a mismatch in a state and you do an action. Well, now we've added, as it evolved, we've added the capability to detect transient states and to take actions off of those transient states, right? And that means, okay, the resource is coming up. As it's coming up, there's a state that's indicated with that. So you might want to do something else while it's coming up. Okay. And then on the reverse side of that, when that application gets into its matching states, whether it be an up or a down, you may want to take additional actions. Like once it comes up, you may want to go send messages to everybody and say, hey, we're now ready to work, get busy. Or once it comes down, you may want to run some backups. Right? So there's a lot more points we're adding in to interact with the transition of resources from up to down. Now that's the simple, most common things that are done with resources. There's also capabilities there to detect when these resources fail or have a problem. Right? Yeah, and it happens, unfortunately. So you could also pre-program actions based off of some sort of condition that the resource got into.
This sounds a little bit like self-healing to me.
It is somewhat, right? Now, you got to understand, automation has been around for many years, right? And it was never really known until more recently when it became more popular with some of the social media things mentioning it, right? But we've been in the automation business for years.
Yeah, I mean, computer systems are automation of processes.
Right. It's a continuing process.
They have been hand in hand from the birth of the computer, I would say. And that's really interesting because it gives me a perspective of how deep do these automations, these self-healing, these processes, if these then that actions that will happen, or how we keep controlling some of these states of the computer and of the mainframes or cloud or whatever you want to call. And how does it relate with this instrumentation, this observability of our mainframes, our platforms? Is it linked up to, because these functions, I'm guessing, are pulling this type of information to take these decisions on the states, right?
Yes, there's a lot of observability that you can get out of this. For one, what we see a lot of now is these one-look observations, meaning I want to take a look at my system and see if everything's okay.
Mm-hmm.
Well, when you take it down to those resource levels, right? And let me just take a sidestep here. It doesn't necessarily have to be a resource like we're thinking of an application, right? StateMan can monitor hardware items,
yeah,
like lines, RETAM lines, like DASD,
mm-hmm.
right? So you can get quite sophisticated into what you want to monitor here. When you do that now, if you push that observability up, right, you can see, okay, everything is good here, or no, we have an exception here, and then we can drill down to see where that exception really is. Meaning, okay, here we have an application that's having a problem, but the application's running, something else must be wrong here.
Mm-hmm.
So you can drill down that way. Once you see that quick view, that look that says, okay, here's an exception, let me drill down and find out what that is.
Is this a little bit related to application exceptions or drilling down? I don't know at mainframe tiers, how deep can you go and dig into these possible sources of errors? Is it similar, or can you dig deeper?
No, you
even at
can. You
mainframe
can.
tiers?
When you have a problem or you want to dig down deeper, there's various pieces of information that you can go gather. From an ops standpoint, we have a log of activity.
Mm-hmm.
Right? So we can take this log of activity and profile through it or filter that activity to say, okay, here, give me all the information about this particular application that's having problems. So you can take a manual look there at that point in time where you're drilling down and say, okay, everything's good. Ooh, wait a minute, there was an error here that we've never seen before.
Mm-hmm.
Right? So then, okay, you can take off on that, maybe find out what that error really means. Maybe it has some codes to it. Look those codes up.
I love that. I mean, no matter if we are talking about a a web server, or just a mainframe, because some of these digging down, I'm sure that could be even tracked down to CPU temperature, or queues, like getting wonky.
Yeah, I mean, we interact with a lot of other products too. Like like OpsRex
Integrations.
can go talk to SysView and get
Mm-hmm.
information from SysView. Maybe there is a job that's taking up a lot of CPU and causing everything else, all your money making applications to run a lot slower, right? Somebody's sitting at an ATM and they're not getting a response. Maybe it's because some other job that
In
somebody's
another
testing.
system or another
True, it could be.
component.
Yes. So you can do a lot with automation that way. You can find out a lot of information, and like you say, you can do a little bit of self-healing. Maybe the cause of this problem is a database or a log is full.
Mm-hmm.
Maybe you switch to another one with a simple command.
Create an automated process that just like
Right.
we need
Right.
extra database. And that's more or less how some of this elasticity works nowadays. I'm guessing, like allocate more resources, or
Right.
limit the RAM for this instance.
And that's another area that ops can touch. Now, the thing about ops MVS is, in reality, it's a big toolbox,
Mm-hmm.
right? And the system state manager thing it's a big piece of that toolbox, but it's only one piece of that toolbox. One of the other things that ops can do is it can talk to the hardware console,
Mm-hmm.
right? And it can go out there and automatically adjust CPU weights if you want, right? So there's interfaces into that sort of capability, and there's many of them.
And there are so many other performance counters that you have mentioned that at times, going now into the performance testing realm, we often do not think that much about. It's like just a database process getting slow, or my HTTP requests just took some more time. But here you're mentioning some interesting things, that how do we know the CPU allocation to what am I working is affecting my performance? We have a situation with another friend that is checking, like, hey, why does my instance in, I think it's Azure, can't, yeah, it's Azure. When I have one CPU, I'm seeing some pulses in the response time. When I have 4 CPUs, the pulses almost disappear. 8 CPUs, no pulses. And some of those things that are performance issues, that when you are getting slowness, or the CPU gets consumed highly, how do you dig deeper and how do you check some of those things? Many are like, no, it has to be the database. It has to be like a missing index. But here you're really digging into even some queues getting stuck in the CPU or things like that. It's incredibly powerful what you can.
Yes, it can be. It can be real powerful, and the interaction there of all these different items can really help a lot. Like one of the things is, you could have a copy of ops that runs well. You're supposed to have a copy of ops that runs on all these LPARs, right? That are all connected in a sysplex, right? Well, each one of those copies of ops can talk to each other, right? So you can send commands over to that one and say, okay, how's your CPU's running now? And you can go in and check it from that level. And you say, we're running really slow. Give me one of those processors, basically. So you take a processor from that LPAR, assign it to this LPAR, right?
Oh, wow. Yeah, because you're what is the not trial and error, but you're switching to see what is happening and what is getting stuck in the other one. Right. Is this like a problem that you can find at a hardware level or logics?
At this level, you're probably looking more at a software level. Right? Oh. You're not really, although you're interacting with the hardware, right? You're taking hardware resources and moving them around, but it's really all dictated by software.
Interesting. And earlier you were mentioning that you had some examples that you were presenting. Could you share a few?
Yeah. One of the biggest ones is the evolution of data processing, right? Been around for many years now, and as people have come and gone, more people are starting to go, right? So we're seeing a lot more of the younger generation introduced into the mainframe. So one of the things that we wanted to address was make it easier for this younger generation to work with these older green screens, these older applications like Ops MVS. So one of the StateMan offerings that we came up with was a panel-driven option, right? That made it easier to configure and administrate or system state manager. Right. So one of the complexities with system state manager was there was disparate data. Right. You had these things called rules over here. You had these things called tables over here, and then you might have some rex execs over here. Right. So it's kind of a disparate thing. What we did with the policy manager application or feature of system state manager is to combine those all into one screen, so to speak, right? So you can see everything that's associated with a resource from one screen or associated with an application from one screen, actually one row in an RDF table, really, right? So associated with that is like all these states you got to do, the rules that detect when something might be up, when it's down, what kind of commands you would issue off of that, will all be combined. And that made it a lot, we think made it a lot easier for customers or users that are new to Ops MVS and System State Manager be able to get off and running real quick. In addition to those sort of things, we've also had capabilities with the policy manager now that we can syntax check stuff. Right? Because one of the nice things about Ops and one of the drawbacks about Ops is it's so customizable. It's a lot of free form, right? As older users out there, experienced users, they know what they're doing. They want free form stuff, right? Just give me a blank screen. I'll throw my Rex code in there and off it goes. Well, a new user can't do that, right? Also, a new user
might come and find all the things that the previous operator was using, and we'll be like, whoa, what is it? That customization gives openings to the lack of standardization, I'm guessing.
Yes, that's whole nother area, standardization and documentation, right? We're finding now as more and more people are retiring that administrated ops before, didn't leave very good documentation around. And in some cases, they're just let go without any turnover to somebody new. So what they do, they call into support, and we got to try and figure out what their automation is doing for them.
There are several things. Just a very quick description for the ones that do not know Rex. What do you mean by that?
It's a text-based language.
It's another language that is what is being used for the base operations management too.
What's a good way to describe it? It's been around for a long time. It's a scripting type language. Mm-hmm. Okay. There's a couple flavors of it, right? IBM provides Rex with the operating system. Mm-hmm. Okay, so it's a base language that's there and available, and you can run scripts.
Some of these configurations and automations or dependencies are in this language, and this is how you just for whoever is watching that may be interested on getting into it. Mainframes still require a lot of young blood, I would say.
Oh, yes. Yes.
And that's another comment on what you mentioned on this dashboard, like getting everything from different places and a single one, helping the younger generations. I'm sure that it helps also the veterans, because having everything in a single screen, and not to paraphrasing a little bit with operating systems, switching windows, trying to see, and like, mm-hmm. This one is this and this one is, if you have them together, you can correlate, you can see some of these causes. So I see some of the advantages of what you're saying. Definitely, there's gonna be a benefit out of that. But also, being a little bit respectful of your time, to ramp down, unintended. What is the relevance with this and performance testing? Would you like to give some words to the audience? Why is this important?
Yeah, performance in testing, mm-hmm. go hand in hand with automation, mm-hmm. right? It goes everywhere from like taking those Rex instructions and making them perform better, mm-hmm. to the measurement of how long it takes this application to go up and down, meaning maybe your ATM machines might not working for a period of time, mm-hmm. your CICS transactions may be suspended for a while, right? So the faster that can get done, the better.
And it's something, I love how you are describing it, because most of the time, the performance engineers are obsessed with HTTP request response time at a volume. But you're touching on crucial things that are performance testing. How long am I getting this machine or the CPU booted? If a failure happens, how fast am I getting it back? As you say, how long is my the ATMs of this state are going to be down because I'm rebooting? Just because of that. It doesn't have to do with users interacting. It's just like, I turned it off, how long it takes to come back. This code that I generated to keep the process running or react if anything happens, how performant it is, has nothing to do with load testing, which is all the rage and everyone gets
right. It doesn't. Yeah. I didn't even touch on like IPL and an LPAR, right? System state manager can do that really quick, because you have all these applications defined. You can give it a simple command to say, okay, take everything down, right? Mm-hmm. And since all these applications or all these resources on the statement have been defined as prereqs and subreqs, right? Meaning, okay, this one comes down first. When it comes down, these other 10 can come down. When those 10 come down, these other 5 can come down,
just a cascading effect like crazy.
Right, it comes down really quick like that, right? Rather than, you in the old days, you would have a manual operator do that. Or without a sophisticated tool like Ops, you would have a script, right? You could base a script off of Rex, and in there you would have a wait in between everything, right? Mm-hmm. So with all that waiting, you're wasting time, mm-hmm. right? You're tying up things, and the faster you can get that machine down, the faster you can get it back up. There's a good performance measurement right there.
And as you mentioned, the complexities increase the dependencies.
Yes.
And
yes.
Before, I remember like some operator just typing them, I'm going to kill the server. Let's see, I need to reboot or reinstall. 3 things went down. Nowadays, if you do that, I'm scared of counting how many things will go down. And as you mentioned, the cascading effect, because that thing that depended on this, 3 more may depend, and then it's like a chain effect like crazy. But this shows us how many dependencies, how important it is to stay on top and understand of these languages, what Rex does, what Ops is taking care of. and how the interactions with performance testers, with operators, have to establish these languages, because it's really important
Yes.
not to just be sending HTTP requests. Teron, thank you very much. If anyone watching this want to follow up with you or check what are you up to, where can they find you?
Well, I'm at work all the time, for one thing. But you can email me anytime. My address is mtyrone.lestoria@broadcom.com. With any questions about ops, I'll happily respond to you. There's also some upcoming events that you may be interested in. This year, there's a series of 3 technical events that Broadcom is putting on that Ops MVS will be heavily involved on. They're called Mainframe Technical Exchanges. There'll be virtual and in-person events. There's one coming up in Prague, Czech Republic, here in a couple months. That's going to be an in-person event. Later this year, there's another one in June. I forget the exact dates, but that's in Plano, Texas.
Check it out. Do a web search. Look for Plano, Texas.
Well, look for MTE, Mainframe Technical Exchange.
Okay. Well, Teron, thank you very much for coming and talking and sharing some of this knowledge. Super important things that we also need to be attentive to and not forget. The cloud doesn't fix all the problems. Actually, it's bringing lots of interesting things. So thank you very much for being here. Everyone, we'll be back with some more interviews, with some more talks, reporting from CMG Impact 2023 at Atlanta, Georgia. See you soon.